Hello, I think we are live. Uh, Let me just check once. Are we live? Yeah, okay, we are live. So, I just tell you the agenda. So, today's agenda is mainly GFG problem of the day and LC problem of the day, and then, if time permits, time and energy permit, we will move to we'll solve some graph questions from crash sheet. Okay, everything in Java. So yeah, let's get started right away. So this is today's uh, this Leetcode daily challenge, which is give me 1 minute. Give me 1 minute. Yeah, okay. So this is today's Leetcode daily challenge, which is Pascal's triangle. This has been marked as an easy problem, but yeah, uh, let's just solve it. So basically, we would be given an integer, and what we have to do is we have to, okay, return a list of integers, and okay, we need to return a triangle based on the calculation. So if you calculate this, okay, let's do one thing. See, in num rows, basically tells us how many value would be there in our this array. Okay, basically it's a list. So let me do one thing. We can have one. See, there are a few base cases. One is if rows of 0 is equal to 1. We don't have much options. Our list of integer would be 1, right? And if uh, if it is 1, it will be that. Other For all the other scenarios, we can compute this value. Okay, so in other scenarios as well, wait, let me create a list. Wait, this is using Java info open 21. Okay, okay. So yeah, let's create a list of integer result, and that would be list of 1. So we will simply return the result. In all the other scenarios, we will proceed to append things to our result. Okay. Uh, Give me 1 minute. I just want to note down something. Yeah. Okay. Let's continue. So yes, basically here, uh, if it is if nums of rows is if we only have one entry, if only one row is requested, we simply return a result. For all the other scenarios, we will start to prepare more list. Okay, now we will start from I equal to 2, I is equal to nums of numbers, because I equal to 1 we have already handled. Okay, uh, so wait, what we have to do here is we have basically I have the previous list, right? So the first and the last index of any row, first and the last index of any row would be 1. Okay, and for the other indexes, I'll have to do some calculation. Basically, I have to handle some calculations. Yes, so I need to handle list, right? Okay, so this basically means we are on the second row right now. Actually, this doesn't really matter on which row we are. We just have to figure out a way. Okay, since we are on the second row, we know there will be two entries. Okay, so yeah, we know there will be two entries. This entry and this entry. And similarly for I equal to 3, there will be three entries. Okay, what I have to ensure is if j is equal to 1 or j is equal to I, it means if it is the first or the last entry, we will append. So for every row, we will have one like list of integer, right? So let's just call it row and let's just initialize it with new array list this. And in here, we would just do row dot add and we would add j for the first and the last. Now, other than that, when j is 2 or something, 2, 3, something like that, in those scenarios, j would be the previous summation of previous these two values, right? Okay, in a list, it's quite difficult to access things via index because I have to access the previous row. Okay, I have to access the previous row. Okay, let me just add the question number in chat. Okay, let's see. Okay, so we have created this. Okay, we need the value from the previous row. Okay, so okay, let's do one thing. To get the value, what we can do is we have a result, right? Okay, yeah. So what we will do is we would access the access the row, the previous row, right? So I is maintaining our row, so we will go to the previous row, and inside that row, in the previous row, I want see if it is like think of it in terms of indexes. This is 0, 0. Second, this is 1. Okay, now if you think column wise, the entire first, the all ones are 0. Then this 1, 2, and this particular line is 1. Think of it like that. So when I have to calculate 2, I have to go to the previous row and I have to get the current J as well as the previous J. Okay, this. So if you just try to visualize it, this should be easy enough for you to understand. So this is done, and now yeah, we can just do dot add well, and after all of that, we will just do result dot add row. Okay, and after all of this, we will run result. Yeah, what is the issue? Result dot add row result dot add row unsupported operation. Okay, let me do one thing. Let me prepare an array list. Okay, let's see if we can handle this itself inside in here only. I will start from this and we're trying to access the basically for the first row we only have one, right? We only have one. So we just do this. Okay. Or wait. For the first row we only have one, right? So I is equal to one. So this will be only one and this will be one. And so okay, it should be handled here. Two, index 2 out of bounds or length 2. So this is 1, sorry, this is 1, numbers 5, okay, this is 1 in here, the first row, and we are saying iterate from 1 to 1, if j is equal to 1, we dot add j, we add 1 and then we append this. Again we start I equals 2, so 1 to 2, so when it is 1 or when it is 2, okay, sorry, we will append 1, right, for the first and the last. Also, now when it becomes 3, when it becomes 3, we go from 1 to 3, and then we go from 1 to 3, and then for 1 we add this, for 2, as equal to 2, what we do is we get the result of get I minus 1. So we try to access the previous index, dot get j minus 1. Yeah, right. Actually, this loop is failing for this one only because in here we only have one index. So it is trying to access j minus one, j minus one, j is one. That is fine, but it won't be able to access j. That is the issue. Yeah, that is the issue here. So what should we do? Uh, we are handling the first and the last position. But this should only work then. Okay. But okay, wait. If j is equal to I in here, then 2 is there, it should automatically add just 1, right? Why is it going inside this loop? Wait. Let us check what is the issue. Uh, 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 okay, my bad. Uh, Array list starts with 0 as index, right? I am using 1 based indexing. Totally, my bad. So we should shift to 0 based indexing. Uh, yeah, okay. And 0, yeah. So this is these are silly mistakes which we tend to do in an interview. I had an interview today and uh, I did two silly mistakes like these. Anyways, this is done. So we are done with the LCDV challenge. So let's go ahead and solve CFC's daily challenge. What is the question? Balancing consonants and vowels ratio. Okay, you are given an array of strings. Okay, where each given an array of strings where each array consists of lowercase English alphabets. We need to find the number of balanced strings in ARA. This can be found by concatenating one or more contiguous strings of array. Okay, a balanced string contains the equal number of vowels and consonants. Okay, so but what does this mean? Find the number of balanced strings in ARA which can be found by concatenating one or more contiguous strings of array. So are they trying to say that we need subarrays? Or like, yeah, we need substrings which can be, you know, which have balanced number of consonants and vowels, and we can also have number. Okay. So let's do one thing. Below this every word, I'll write its consonant count and I'll write its vowel count and I'll try to figure out if there is some relation there. Okay, you know. So here A, E, I, O, all are vowels. Here all are vowels. A, E, I, O, U. Here two are consonants. Here one is consonant, and in here uh, all are consonants, right? So now vowels. Here four are vowels. A, E, I, O, U. Two are vowels. Here two. Sorry, zero. Here one, and here I check zero. Okay, now, now, see, initially, if I, basically, if I'm able to create an array like this, like I'll create something like component and vowel, and I'll have this integer array. This one and this one are same, so it automatically is present in the answer, which means the number of C and V are balanced. Actually, if we take prefix sum of number of consonants here is 0, number of consonants here is also 0, number of consonants is 2, number of consonants is 3, number of consonants is 7, number of vowels is 4, number of vowels is 6, number of vowels is 6, number of vowels is 7, number of vowels is 7. Does this help us in any way? Is 0 to 4, 0, 1, 2, 3, 4. So it is saying that in the entire string, okay, it is equal because we have 7 consonants and 7 vowels. So the prefix sum tells us that. Okay, 1 to 2 also has. Actually, let's think if we can apply some difference array technique over here. Basically, that states something like that if a thing is basically we have prefix sums, okay, which means I have some data from 0 to ith index, okay, and 0 to z index. So difference array states that we can using this data we can figure out the calculation between I to jth index. So this is what difference array states. So here if you see 0 to 4 it is evident because 7 7 it is same, which means that uh, when we come to the last index, the number of vowels and consonants are same. Now it is also mentioning in answer 1 to 2. So 1 to 2 basically means let's check from 0 to 2. So 0, 1, 2. So 0 to 2 if we check, number of consonants is 2, number of vowels is 6. Let me just write 2 and 6. No, not this one. 2 and 6. Okay. And 0 to 2 would include, sorry, 1 to 2 would include 0 to 2, and it will also include 0 to 1. Sorry, sorry, 0 to 1. So 0 to 1, if I check up till this index, we have 0 consonants and 6 vowels. Okay. Hmm. Does the difference give me anything? Okay, let me think about it. We received 1 to 2, right? Yeah, okay. 1 to 2. If we see 1 to 2, we have two consonants and two vowels. Here, if you see, we have two consonants from this part to this part, which means, and in this 0, which means in this part specifically, we have two consonants, which is true. For vowels, it is mentioning that we have six vowels from 0 to 2, which is correct, and we have six vowels from 0 to 1, from 0 to 1. A, E, I, O, A, which is also correct. Okay, 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 okay. So when we take the difference array technique, uh, array 1 to 2, 0, 1, 2, array 1 to 2, uh, basically I think the last index is not calculated in here. So what is happening over here is when we are taking 1 to 2, we are not considering 1 actually. Okay, so see, 0, 1 to 2 would basically mean 0 to 2 and 0 to 0, like 1, we have to stay at a previous index. Okay, so that is important. If I now see up till 0, my consonant, this is 4. Right now, what does this tell me? That from 1 to 2, this will tell me that from 1 to 2, we have two consonants and two vowels, the subtraction. So yeah, I am quite convinced that this technique could be used here. Okay, but I just want to wait. I need to add it to my to-do list as well. So it's a very important technique. Recently, I'm encountering this technique of the web. So difference array technique. Okay, okay. Now, now. I just need to, you know, let's try implementing it because I have understood the logic, but let me try implementing it. Okay. So basically, what I'm saying is that I need a consonant prefix. So I'll just call it C prefix or CSUM. Yeah, CSUM is fine. It should be an array, and I need a PSUM, which is vowel sum, and this is so now we would iterate through the array. Okay, so string string current is equal to arr of I. Sorry, wait, let me add this now here in the chat. Solving, balancing consonants and vowels ratio, CFG, TOTP. ठीक है. So I've taken the current, which is AEI. ठीक है. Now what I have to do is I have to calculate the number of the consonants and this vowels. So let me do one thing. Let me do one thing. I'll create a separate function, private and uh, count vowels, and we will receive the string current. Okay, and in here I'll check. So it is saying constraint is lowercase English characters, lowercase English alphabets, right? So I can simply just add a check that if current dot contains a or current dot contains E. Acha, no, wait, I need a count as well, right? So let me do one thing. Let me do one thing. I need the count. So to check this, okay, yeah, I only need the count, right? So one thing I can do is current dot length for int I equal to 0, I less than n, I plus plus if, uh, okay, let me see, char c is current dot char at I. Now, if c is equal to a or c is equal to e or c is equal to I or C is equal to O or C is equal to Q, A, E, I, O, U. There may be a better way to write it. Obviously, we will look at the solutions, but first let's just try to solve it on our own. So I have to return the vowels count. So let me take a count, and in here we will do count plus equal to 1, and in here we will return the count. We also need a private int count consonants, count consonants. In here we will work smartly. We will not uh, do this calculation again. What we will do is we will return n minus count, because sorry, n minus count vowels for this current, because in vowels we will count calculate number of vowels, and then in here we will just subtract it by the total length. So yeah, after this I'll receive it, but for now let me copy this function. So for string current this if now, yeah, okay. So what I have to do is int vowel count is equal to count vowels for current int console. I'm not writing entirely, so consonant count is equal to count consonants for this string. So now what we would be doing is we would go to CSUN, and we would say now one thing is that uh, okay, so one thing is that see some of index. So if I is equal to 0, at that time it would be just the console count. If it is not equal to 0, it means we have a prefix, we have something previously used, so I minus 1 plus console. count. Same stuff for our vsum I equal to I is equal to 0. Just add the vowel count. Otherwise, we would do vsum of I minus 1 and we would add the vowel count. Okay, so yeah, this is uh, basically after this I am assuming that we'll get some array like this. Let me just remove this part. Yeah, so I'll get an or let me also move these functions below. These are helper functions. So let them be here so that we can see the program correctly. Yeah. Now, now we have this initial thing. Now we want an answer, right? So we need to follow the difference array technique. Okay, let me try doing that difference array technique in here. So basically, we would iterate to the give me a minute. Uh, Actually, I'll have to create a difference array. I think. Let me see. We have this 0 4. Okay. Um, Let me see. Wait a minute. What does the question state? Count balance. You have to count the balancing this. You have to count the balanced number of calls. You basically need the you basically need the count. Okay. We need the count of all the sub arrays. You can think of it as sub arrays or substrings. Okay. So okay. Let me see if I create some diff array. Okay. I'll say oh this is like vowels minus consonants. So let's help me vowels minus consonants. Okay. Okay, so it is actually telling me the difference, right? Difference between the number of vowels and consonants in this position. Okay, yes. So I probably need that. See, I come here, I say this is equal to b sum of I minus c sum of I. Okay, this means, see, it is telling me the difference in the number, right? We want that difference to be zero. We want the difference to be zero. Right, right. So now I just have to iterate through this diff array. Okay, I'll iterate through this difference array. And now what we need to do is, okay, yeah. So in difference arrays, one very important thing is if you see any YouTube video, is in the start we should just push 0 and its frequency is 1. Basically here we are keeping track of whatever differences we are getting along with the uh, number of times it's same. So initially when it is array is empty, we are getting this 0 1, right? So here what we would do is um, um here what we would do is, so I'll also need a prefix sum. I'll also need a prefix sum to calculate the current stage where we are at. So plus equal to x. Okay. Now, now in our result, we would check. See, prefix sum is right now 0. Okay, and difference is 4. 4. So what we would check is, do we have this? Do we have this? Which means, have we seen this difference before? Have we seen this difference before? Okay, and whatever its frequency is, right? That would come. That would be counted in our result, and then we will just add this current prefix sum, and we will do this. Yeah. After that, we can return the result. Let me see here. Are we doing anything wrong? What is output is 1? Output is 1. Output is 1. This difference array, am I doing some issue when calculating the difference array? Okay, wait. For difference array, again calculating, I don't need this. I don't need the prefix sum. I need this. I need the vowel count minus consonant count. Wait. Yeah, I don't need that at all, because that is unnecessary. We are calculating the prefix sum as well, and then the difference array is for that prefix sum, right? So we are doing same thing twice in two different registers. That is why this is a much more cleaner approach, where we just prepare one difference array. Okay, so let me just remove all of this. Let me also remove this thing, or let me just replace these with the actual values. Consonant is 0, vowels are 2, consonant is 2, vowels is 0, consonant is 1, sorry, vowel is 1, consonant is 4, and vowels are 0. Okay, now what we are doing is we are preparing the difference, which is 4 minus 0, 4, 2 minus 0, 2. Okay, no double calculation. Okay, again 0 minus 2, minus 2. Then we have 4 minus 1, sorry. 1 minus 1, 0, and here again we would have minus 4. See, okay, this is fine. Now we have created our difference array. Let me copy paste it in here. Okay, now we are saying prefix. We are taking the frequency map, which is important to keep track of what frequency, or what this count we have already seen before. Then frequency dot put 0, comma 1. So initially we just say that, okay, we have seen the prefix 0 once, because when we are not taking anything, the other the consonants and vowels are balanced, right? They are both 0. That is why 0 is 1. Okay, and result is 0 and everything. After that, what we do is we iterate through it, so we get 4. Okay, so we add 4 to our prefix sum. We have a prefix sum, we add 4 to it. Okay, which means, so this means from 0th index to 0th index, the prefix sum is 4. Okay, now what we are checking, have we seen this 4 before? Have we seen this 4 before? No, we have not seen. Okay, no problem. Result stays the same, but let's add 4 to our frequency. Okay, yeah, okay, let's do that. Now we come at 2. Okay, prefix sum plus equal to 2. So prefix sum, let me add 6. Have we seen 6 before? No, no, yeah, we have not seen 6 before. Okay, no problem. Add 6. Add 6 to this. Okay, now we are checking. Sorry, now we were at 2, so now we are at minus 2. Minus 2 basically means 6 minus 2, 4. Have we seen 4 before? Yes, Yes, we have seen before. We have seen code before, right? Once. So our result will get incremental. So you can do the trial, and you can also read about the range array, or I think it is called difference array or range array technique, something like that. But it is very important, and that these days I'm finding too many questions which are being solved via this difference array technique. So you can go through it, and I'll try to someday solve just difference array questions so that we can understand the pattern really well. But in here, yeah, this was too good. And so once you understand a range array technique, now you will really love it, because automatically you see a question and you'll understand the pattern. See, I was able to understand the pattern here. It is difference array technique, but of course we need more practice on the implementation part. Okay. So yeah. What should we do? We are done with this question. So okay, I think I'm not submitted it, right? Let me try something else. Okay, question is submitted. Okay, this is fine. So let's move ahead. We have done the balancing consonants. We have done that. So both problem of the days are solved. How many? Okay, it's only 36 minutes. So let's continue solving questions. Some more questions. Find eventual safe states. So this is Faraj sheet. Uh, this is Shiva Faraz. So I'm solving this right now. And in graph, if you see, I've solved these. The questions which are marked as green, yellow, or red, whatever, I've gone through them. So yeah, I'll move to this question. Find eventual safe states. Find eventual. Find eventual safe states. Yeah. What is the question? There is a directed graph of n nodes with each node labeled from 0 to n minus 1. Okay. Graph is represented by a zero index to the array. Okay. Okay. Basically, here we have uh, like each of these indices is representing a node. So to have to keep track of the number of vertices on the graph, I will have to get graph dot length. So this is basically the number of vertices, and these are zero based index, it's like zero indexed. Okay, so graph is represented by a zero index to the integer array graph, where graph of I is an integer array of nodes adjacent to node I, meaning there is an edge from node I to graph of I. Okay, I got it. So we need a what do we say? Adjacency list. So let's prepare an adjacency list. Now adjacency list would be for all the vertices. Yeah, and wait, I cannot maintain. Let me just do it like this. Sorry, there's an issue. My browser suddenly just restarts at time. Okay, I don't even know if streaming is totally fine or there is some issue with streaming. Let me check. Mm. Okay, let me just check if streaming is totally fine. Yeah, I think streaming is fine. I'm not sure if it got disconnected or something. Um, Solving 802, find eventual safe states. Yeah, okay, okay, okay. So yeah, what I was doing is I was trying to create a adjacency list which would hold the data for me. Okay, adjacency list. Um, okay, okay. Actually, okay, let's just solve it first and then we'll talk about some things. So yeah, iterating through it. Now inside this, I'll get the list of adjacent nodes. Adjacent node is equal to adjacent nodes is equal to graph of I. Correct. So I'm getting one thing, which means from I, which is 0 to 1 and 2, there is an edge, right? So I should add adjacency list. Okay. One thing is compute if absent of put if absent. Okay, wait. Adjacency list dot get I dot put if absent new array list. Okay. Now what I can do is adjacency list dot get I dot add. What are we trying to add in here? The adjacent nodes, right? So let's iterate through the adjacent nodes. Let's iterate through the adjacent nodes and adjacent nodes node. Yeah, add node. So I am able to prepare the adjacent list. Okay, now what I have to do is, as I didn't read the problem statement, I started, uh, you know, creating this adjacent list. So graph is represented by this is an integer array. Okay, node is a terminal node if there are no outgoing edges. Okay, a node is a safe node if every possible path starting from that node leads to a terminal node. Okay, we have to return all the safe nodes. Okay, what does this mean? A node is safe if every possible path starting from that node leads to a terminal node. What are terminal nodes in here? The game I've shown above, nodes 5 and 6 are terminal nodes as there are no outgoing edges from either of them. So 5 and 6 are terminal nodes. Okay, that's good. Every path starting at node 2, 4, 5, and 6 all lead to either node 4 or 5 or 6. What is wrong with 0 then? From 0 you can go to 1. Okay, from 0 you can go to 2. But from 2 we can go to 5. 4 we can go to 5. Okay, okay, okay. So a node is a safe node. It's a safe node if every possible path starting from that node leads to a terminal or another safe node. Okay, so terminal node is something where there are no outing edges. This we can easily figure out. Actually, no outgoing edges means that this is empty. You see, this is empty. So we can figure out the outgoing edges thing. But what should we do? Return an array containing all safe nodes of the graph. Basically, if I start from 0, I can I can go to 1 and 2, not to the terminals. If I start at 1, I can go to 2, 3. But 2 is a safe node. I think I'm overcomplicating it. Let me We read the problem statement. So let me drink some water. Uh, so 0 to 1, 1 to 0 to 1, 1 to 2. Why? Okay, see, it is marking 2, 4, 5, 6 as the safe nodes. Okay, that is fine. Why it is not marking 0? From 0 we can go to 1, from 1 we can go to 2, from 2 we can go to 5, from 0 we can go to 1, 1 to 1 to 3, 3 to 0. Okay, 1 to 2, 2 to 5. 1 is 1 to 3, 3 to 0. Okay, 3 to 0, 3 to 0, 0 to 1, 1 to 3. Okay. Actually, this thing somewhere means that that particular node should not be part of a cycle. Because if you think, if you look carefully, from 0 we are going to 1, 1 to 3, 3 to 0. It's a cycle, right? It's a cycle. That is why it is not ending up at a terminal node from where none of the edges are outgoing. Because from for one as well, if you see 1, 1 to 3, 3 to 0. For 3, it's like 2 to 0, 0 to 1, and 1 to 3. That is why. So basically, that's what we have to figure out. Uh, the cycle thing. Okay. Uh, okay. Arey, give me 1 minute. Yeah. Okay. So let us continue. Uh, so basically, we somewhere need to figure out the nodes which are ending up in a cycle. Okay. Basically, see, there is an algorithm, Khan's algorithm, which will come to your mind if you have read about graphs. Secondly, if you have gone through Striver's playlist, this Khan's algorithm is used for topological sorting. Okay, and it somewhere uses this concept of incoming edges. Okay, now here what we have to do is basically there we start with nodes which have incoming edges equal to 0. Okay, here we have to start with edges where there are no outgoing edges, which means basically, we have to reverse the implementation. So to reverse the implementation, let me do one thing. Let me first maintain a array to calculate the out degrees. Okay, and in here, what we would do is uh, we would reverse that, right? Which means we will wait. What we can do is we have been given the graph. Okay, and adjacency list, it would be a reverse list. Okay, so new array list is okay. And yeah, so one thing I can do is I'll iterate through the given uh, this thing, and I will do one thing, adjacency list dot add new array list, so that I have those many entries, and then we can do this in, we can, yeah, this is fine. We can move from 0 to n. And in here, what I could do is so basically our degree would be the number of nodes in present in here, right? So it would be graph I dot length. Yeah. So our degree for 0 is 2, right? 1 2. Our degree for 0 is 2. right? And in here, uh, we are iterating through this graphify, and in here we'll have to reverse this. This is very important so that we can handle the reversal of graph. Okay, and in here we will be having I yeah yes, this is totally fine. So this is not required actually. I mean we had it there. Uh, it's the same stuff. It will not cause any issue, but let's just remove it. How degree? Okay. Yeah. Now we can do the multi-source PFS. New integer tool is equal to new linked list, and for for whatever nodes the out degree is zero, which means it is a terminal node, we will push them, and that those will be our source. Uh, if you are finding it difficult, you should go to the Strivers uh, or DSA Strivers graph playlist. That is really awesome, really awesome. Like it's the best playlist out there for anyone to understand graphs. Okay, so yeah, let's continue. We have added the source. So in source, we are adding the terminals. So like right now, 5 and 6 are present inside of this queue. Okay. Now what we are doing is we will do the topological sorting thing. Obviously, we'll try to follow the Kahn's algorithm. Okay. Current is equal to Q dot pole. Now, see, we are able to reach it by the terminal. So this is a safe node. Okay, let me do one thing. Let me have a safe stuff so that I can mark it as safe. So safe of current is equal to. Should I should I mark the terminal node as safe? Let's see. For now, this is fine. And now we would do adjacent. Adjacent was in adjacency list, adjacency list, adjacency list dot get current. Yeah. So for then, out degree would reduce minus equal to 1, and if the out degree becomes 0, it would enter our queue. Yeah, this is this is fine. We are not using ADJ anywhere, right? Yeah. So this is fine, and after this, we have marked the safe nodes as well. So now after all of this, we can simply return our result. We have the safe nodes with us in the safe array. Or wait, why am I keeping a separate safe array? I'm not using that logic anywhere here. So can't I just create a integer result new array list this, and in here I can simply say result dot add current, and we can return the result. That's it. That's it. Cannot find symbol u. Our degree of I. Our degree of I. What is wrong? Okay, we need to sort it as well. Right. What we have? Let me do collections. Sort result. So we are done. Uh, we can submit it. It is submitted. Okay, where to got to? Yeah. So let's mark it as done. Also, let me note down the points which we followed. Of prepare, out degree, and take how degree 0 nodes as source, multi-source input for PFS, perform regular counts, make sure the graph, make sure the graph at the list is reversed or prepared in reverse manner. That's it, that's it. We have not done too much in this question. Yeah, ठीक है. Let's move to the next question. Keys and rules. Okay, keys and rules. How much time? 45 minutes is done. So let's see. I will wrap up. I'll wrap this stream in probably an hour. Let's see. I'm not planning to stream for 2 hours as of now. Keys and rules. Hmm. There are n rooms labeled from 0 to n minus 1. Okay, all the rooms are locked except for room 0. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. Okay, so basically, 0th room is unlocked. We start at that room and we try to get to all the other rooms. Basic stuff. Nothing different here. Okay, so we just have to, we will find a distance with these. So which room we can unlock. So since here we have one, so which means I can go to one. Here we have two, which means I can go to two. Here we have three, which means I can go to three, which means I can go to all the rooms. So I have written true. Here we have one three, we can go to one and the three. So when I go to one, I can go to one or three again, or zero. None of these are required. I have the three, I can go to three, but I cannot go to room two. Okay, we cannot go to room two. So yeah, this is a pretty basic question. It's a very basic question. Simply have to implement it. So let's just implement it. We have the rooms. Sorry. I sometimes just start using C++, but here we are given a list, so we can do this. I'll have to maintain a visited. I need a queue because VFS is my favorite algorithm in this world. Okay, so we will use VFS. Okay, so visited of 0 is true because of course the question says we start at room 0 and we start at room 0 which means our queue also starts with 0th while not q dot is empty. What is I need to have some count of rooms visited. So 0. Now here I'll say current room is this, and yeah, since I've visited this room now, I'll mark it as, or like, sorry, I will increment this count, and now I have to see what all keys are present for this room. So rooms of current, sorry, rooms dot get, because it is a list. Rooms dot get current. I have to see if I have not visited this particular room, then I'll mark it as visited and I'll offer that. I'll add that to my queue. Okay, okay. That's it. That's the only thing we have to do. So whatever one is not visited, we go there, we mark the things and stuff, and after that, one simple check which you have to do is rooms of visited equal to n or not? And that is our answer. This is very basic question, very basic question. But still, we managed to do some mistake over here. Okay. So, Acha, I forgot to mention this problem in the chat. Let me just write it real quick. So it's done. It's done, and also I think we have streamed for almost an hour, which is enough for today because it's Friday night. Okay. Friday night does not mean that I will not do DSA. It means I am studying something else. I'll do probably some LLD, HLD. Okay. But DSA, this much DSA for today is enough. Okay. Uh, yeah, I think this is fine. Let me just add it. Basic BFS, easy EFS. Basic BFS, yeah. Even rotten oranges is tougher than this question. It should be an easy question. Easy, easy peasy. That's it. So this is done. This is done. This is done. Let me close this. Yeah. Yeah. Okay. So no questions, nothing. So let's do one thing. Thanks for watching. Wrapping up the stream. Wrapping up the stream for now. And let's see. I plan to bring out a video during the weekend. Let's see if I can do that. That would be good, right? So, anyways, thank you everyone for watching this. I will end the stream.